Welcome back to LTIMindtree. This time we will be having a discussion about the future anticipated workload on quantum computers and also explore the transition from awareness into adoption for an organization. My name is Tom Christensen and I work as a thought leader in LTIMindtree. Together with me, I have my colleague Amuk. And before we kickstart the conversation, could you give us a short introduction to what you're doing?
Sure. Thanks, Tom, for having me. I am Amog. I lead Quantum Technology Incubation Unit at LTIMindtree. Here we are building capabilities and expertise so that we can help our customers on their quantum journey towards quantum value for their business.
See, Amuk, the first question that pops up in my mind is, why should organization even consider the adoption of quantum computers over classic computers and high-performance computers, and what is the difference?
Sure, Tom. I think it's important to realize that quantum computing isn't about replacing existing supercomputing infrastructure. It's about supplementing and vastly enhancing our capabilities to solve certain complex problems that are beyond reach of classical computers, especially handling those problems where complexity grows exponentially. These are the kind of problems in terms of like quantum simulation of quantum systems, or optimizing very complex systems. And the reason why quantum computers are suitable to solve such kind of problems efficiently, and that is the core difference between classical computer and quantum computers, is how they process information at a fundamental level in itself. Classical system, as you know, handles the information in bits. It's the basic unit. It can either represent 0 or 1. Quantum computers, on the contrary, works on qubits, which can represent 0 and 1 simultaneously. And this gives it a power of exponential. This allows it to explore multiple outcomes and processes multiple outcomes simultaneously, and thus an ability to solve certain class of problems faster and better.
So the big difference is 0, 1 versus qubit on the quantum computer. That's the big difference when we look at the infrastructure.
Yeah, that's the core difference.
That's the core difference. So if we turn this one upside down and we take a look from a business perspective, in what fields can you see that quantum computer will be value adding to an organization?
Yeah, broadly speaking, what we have seen so far is quantum computing can add value in 4 class of problems, like optimization class of problems, machine learning, simulation, obviously, and security. These are the areas where quantum computing will have significant impact.
Okay, so there are 4 areas where it will bring value to an organization. Could you maybe go into a little bit more details, elaborate a little bit about those 4 use cases?
Sure. Let's double click. So optimization, a combinatorial optimization class of problems are prevalent across different industries, right? Take financial portfolio optimization for an asset management firm, or optimization of complex logistics, right? Or optimizing energy distribution for utilities. All these are complex optimization problems where the complexity of the solutions or the number of solutions exponentially grow as the problem size increase. And that is where classical computer have a challenge to pinpoint exact solution in a reasonable amount of time. And that is where quantum can bring value. The second area is the machine learning space. The initial experiments that we have run, what we have seen is, we are seeing some very promising results in the data classification class of machine learning problems, where quantum properties can uncover the hidden patterns or subtle patterns between different data points much more efficiently, which allows it to classify the data much more efficiently. And the use cases are like, fraud detection, or much more accurate risk classification for an insurance organization. So these are some of the interesting data classification class of problems, but they can be across different industries as well. Third is on the simulation class, right? Simulating a complex quantum system quantum computers are inherently suitable to handle this kind of problems. So drug discovery for pharmaceutical companies, it's a significant example. There is a lot of work happening in that particular space. And finally, the security. Here, quantum computer is actually a threat. As you know, most of the public crypto systems are based on a very complex mathematical problem. And quantum computers, these are the problems where classical computers will take ages to break, and that is the reason we rely on them at this particular moment. Quantum computer promises, there are quantum algorithms that have already shown efficiency in solving such kind of problems, right? Factorization problem primarily, much more efficiently and even faster. So quantum computers are actually a threat to a public crypto system. And that is one of the areas where there is a significant work happening across the globe. There are solutions like post-quantum cryptography. There are tools called QKD, QRNG, which we are also leveraging to safeguard enterprises from a potential quantum threat as well.
Yeah, I think it's clear that, it is bringing a lot of value to the table for business. So in the pharmaceutical sector, as you mentioned before, if you can shorten the time it takes to bring new drugs to the market for maybe 10 years and take it down to 8, it brings a lot of value to an organization. But the next question that pops up is, where do you actually start?
Yeah, it's overwhelming, especially when the technology is also emerging and fast developing. Where should organizations start? So the most efficient way to do is it's a journey towards quantum value, right? That is what we call it. We are there to help customers get jumpstart on this journey. The journey starts with quantum awareness, quantum preparedness, and then exploring incremental quantum value. This is a journey that organization needs to take.
So those are the 3 steps that you need to go through:
Yeah.
people, process, and technology. If you should double down on that and maybe explain each steps a little bit more, what would that be?
Sure. So quantum awareness phase is an important phase where you need to enhance, an organization need to enhance the quantum literacy across the board, right from the exec level to the key stakeholders across different units, and work on a quantum strategy. There is a need to do a quantum business impact analysis in this particular phase to identify opportunities, challenges, use cases, impact on their business, so on and so forth, right? Identify the use cases. That is something that every organization need to start exploring, as which all are the areas where quantum will have a significant impact after understanding what quantum means, right? What it can do, and more importantly, what it cannot do. That is also a part of quantum awareness. From the quantum security side, right? Quantum awareness is having a quantum threat assessment of your landscape to identify the very critical, sensitive vulnerability areas which you need to safeguard from a regulatory and compliance standpoint, as well as compliance and standardization and regulations are coming closer. Second step is the quantum preparedness. Once an organization is quantum aware, once they have a basic understanding, quantum preparedness is a phase where you start building organizational capacity in terms of right talent development, having the right partners who have built right capabilities. There are multiple platforms. Have your platform strategy. Choose the right platform which is rightly applicable to your business problems as well. Try to build prototypes, real prototypes with the real data for those use cases that will have a significant impact on your organization. From quantum security standpoint, start building quantum POCs to safeguard a sandbox of your data centers, for an example, or safeguard your critical applications. So quantum preparedness is essentially preparing yourself to get into a position where you start building quantum incremental value for your businesses, and that is the last phase, and which is a longer phase. And this is the phase where you start looking for those classical workflows where you can integrate quantum classical hybrid workflows to gain incremental, small but incremental value, so that as technology evolves, you position yourself in such a way that you are the one who will be gaining most value as the technology evolves. So quantum incremental value, exploring incremental value, is the final stage. And this entire journey is pretty extensive. And what we have done at LTIMindtree has built a very extensive jumpstart approach where organizations need not worry about these phases in detail, and we can help them on this journey and get them jump-started on this journey.
I think it was a really interesting discussion we had here, and thank you for the insight. What we want to do in LTIMindtree now is to run roundtables here in EMEA over the next 12 months. And what we want to do here is to invite senior leaders into a roundtable for about 3 to 4 hours, meet other peers in the industry, share views, ideas, concerns around quantum computing and how this can be adopted in your organization. We're also inviting other partners to join us, so you have an option to focus on infrastructure, get questions in that layer, or maybe talk about the quantum programming, which is a completely new discipline as well, or maybe doubling down on the use cases and what experience do we have and how can we help you jumpstart that process in your organization. From us, we want to say stay tuned for more information from LTIMindtree.
Thank you.